1965 was a very interesting year, and I'm not sure that there are very many in this group that were alive in 1965. I see one back there. One way to tell would be for me to read the headlines that were in 1965 and see if anybody remembers it or doesn't remember it. Race riots ravaged Watts section of Los Angeles and 35 people died. Early bird communication satellites enabled communication of TV programs between Europe and South America. Soft contact lenses were invented. Space probe Mariner 4 sent back images of Mars. Martin Luther King led a civil rights march to Selma, Alabama. And as a sidelight, 50 years after things happen, you see them show up on TV as documentaries, and we're going to learn a lot about Selma this week. Medicare, a federal health insurance program for the aged, was signed. More than 125,000 American troops were in Vietnam. Mao Zedong's Cultural Revolution began in China. War between India and Pakistan over status of Kashmir. Winston Churchill died at age 91. Ralph Nader published Unsafe at Any Speed. It was just concern of the, what was the car?
Corvair.
Corvair. See, there's a lot of And in 9 northeastern states, 24 million people totally lost their electricity. Did anybody remember being in that 9 million people? Yeah, yes. Boy, we got some people here. And finally, U.S. spaceship Gemini 7 and Gemini 8 rendezvous in space. So 1965 was an important year for a lot of us. And for those who weren't alive and an adult in 1965, this may be a chance for you to sort of see what we went through in order to develop some of the systems that you have today and you take for granted. I hope that after this program is over, you'll think that, you know, our grandchildren will probably be thinking about putting a program like this together in the year 2065, 100 years after 1965. And the things that we take for granted today probably will sort of look dated, sort of like the things that I'm showing you here right now. It's important to know that everything has to have a foundation, and the foundation of all the technology that we have today started with advanced technology. And I break the advanced technology into 4 categories. In 1965, we had computers, mainframes. We had communications. We had photography, and we had entertainment. Now think about your iPads and smartphones. They really concentrate on entertainment, communication, whatever. What's the other one? Photography. You want to listen really close because I'm going to give you a quiz. Our friend Dr. Emmett, where are you? There he is, professor of history down at Point Park University, tells me that every class should end up with a quiz. And so I'm going to have a quiz that I'll be asking you 3 questions at the end of this session. You've heard of open book quizzes, tests. Well, this is an open look quiz. I'll tell you what the 3 questions are right now, and you'll look to see if you can find the answer as you see the show and tell part, the slides, and any other comments that seem to come out. So the first question is, what was Echo 4? What task did Echo 4 perform? The third question is, where is Echo 4 today? So, I expect. Okay, let's start with the computers. There was a lot going on in electronics that led to computers, and I have a couple of items here that, probably this belongs over here in the entertainment, because it says that the black and white VCR camera cost $2,200. And I'll put that there in 1967. Then we have Heathkit. Of course, has anybody ever heard of Heathkit where you, oh boy. I've paged, what do you call this, putting little tabs, bookmark the pages that show the items that we built in Heathkit. And there's a lot of fun in this catalog alone. In 1966, Scientific American had a lot of ads that are really interesting when you look at them today, 50 years later. Memories in computers were magnetic cores, and this is a very small core array. And from those magnetic cores, you could store data, and retrieve it, and use it like we use the SD cards in our cameras and stuff today.
How many bits is that?
I guess this is maybe 8 by 8 times 4. Yeah. 4 words. Westinghouse, of course, had to have something different, and so they made these, as Chris could tell us, the NOR, not OR circuits, up in Buffalo, New York. And this is the one that shows the V notches that were put in there, so that as they snapped these resistors into this little package and then potted it in an epoxy that expanded as it heated up, it pulled those resistors right away from the soldered connections because they were only soldered on about 120 degrees. This is the improved version that we did here in Pittsburgh that shows the transistor and a circuit board with drill holes. And so they can be heated up, cooled down, and it never failed. A NOR circuit is like a brick in a building. You could take enough of them and build an entire logic system, arithmetic system, word processing system, and it takes a lot of them. But when you look at it, the very lowest element in a computer, you'll see either a one transistor element. Now, it happens today, of course, they have billions, a couple of billion transistors on a single chip, and the cost has gone way down. The core memory that we had in Echo 4 cost $50,000, and it was just 16K bytes. If you look at an SD card that you can buy for $25 now, it's a factor of about $2 million times. So if you move that 50,000 times 2 million, $100 billion that you'd be paying for that much memory if you were stuck with the magnetic core. I have here a punch card, an IBM punch card that was used to store data and programs. If you ever wrote a lot of Fortran programs, you got really familiar with large decks of these punch cards. Here's the circuit board that used both types of the NOR circuits. And by breaking the elements down into manageable circuit boards, you could then pretty well figure out where the problems were when the machine decided not to work. But it was hard if it failed for maybe a minute, 20 minutes after you started, and then it went back to working. You had to be really quick with the scope to see where the problems were. Okay, moving from computers into communication. We have several means of communications. Probably some of you use these little 1/4-inch magnetic tape mailers that you could write, I think, a 3-minute letter to your parents and drop it in the mailbox, and they had a player and they could play this reel-to-reel 3-minute tape. We did this for years. When we were in Spain in the Air Force, we used a magnetic recorder that used flexible magnetic discs, and these were rolled up and put in a plastic tube and shipped back and forth between here and Morocco. And it was a great way to write letters because we had access to the crews as they came in. They needed weather forecasts. So there was a pouch in our weather shop that you could drop mail in, and it was delivered the next day. A good advantage of being in the weather service there. Another way of communicating is to have a good map. Now, these were free at the gas stations. Nowadays, I guess they're free when you go to Google, but I sort of like to have something I can look at. The secretaries used their dictation machines, and they wrote on these plastic discs by a scribe and a stylus in there, and they could play it back and type the letter on a selectric typewriter. And this was the mainstream, the main horse of a good, well-equipped secretary. They loved the selectric typewriter. They loved the sound of it. It sounded to them like a Model A 4-cylinder engine with not the nice cackle. Westinghouse also came out with a product that was used 1/4-inch tape, but they were in little cartridges. These cartridges then fit into the player that was made by Westinghouse, and you could take this with you and write letters and then drop this in the mail, and didn't have to spend time writing. Now, this is an actual genuine dial. And if you look on the back, you can see how reliable it was. The contacts that closed the number of times that you wanted it to. And pretty slow. It wasn't as fast as the touch tone dialing that came out later, but in 1965, this was an advance in technology. And then, of course, stenographers like to have pads to write their notes that they could then transcribe. It's not quite like if one of your teenagers went into a store to ask for a pad, they'd probably come out with an iPad. They wouldn't get something like this. Similarly, have any of you ever used a big cheap tablet in your school? Well, this is what you would get if you asked for a tablet in the stores in 1965. A little different than what you'd get if you asked for a tablet in a store today. Moving on down into photography, we have film that was made by Kodak for bright sun flash. And I don't have any Kodachrome, which made slides, because Kodak doesn't even make the chemicals that could be used to process. If you had a whole room full of the film for Kodachrome, you'd be stuck because you couldn't develop it. There's no other source for developing those things. And of course, to take a color picture, you had to have a blue bulb. And these were the flash bulbs that you had to have in your camera to get true colors when you took those color pictures. Nowadays, you use available light, and you really don't need all that flashing business. Of course, the 35 millimeter camera is not as old as some of the other things on this table, but it's characteristic of 35 millimeter film cameras. We don't see these being sold very much anymore. And finally, here's a Polaroid camera. Has anybody ever used a Polaroid camera? Oh, boy. You know all about it. You could tell me things about this Polaroid camera. But I guess you'd be hard-pressed to find film. I've never tried to buy a roll of Polaroid film, but I suspect you could find it on the internet someplace. Okay, in the entertainment, this is where the things really changed. We've got a CRT television, a color TV. In 1965, that's the only way you could have it. Would be something that weighed probably 100 pounds. Took 2 or 3 people to move around from one side of the living room to the next. In magnetic tapes, you could use this 10.5-inch tape and get several hours of music recorded at 15 inches per second. Or you could buy a 7-inch tape, like Sound of Music, and had the soundtrack of the movie right there in your hi-fi system. Of course, there were 45 RPM records and 33 1/3 vinyl, and a lot of people today still say that the vinyl is the best way to hear the music as it was originally recorded. I have an 8-track player and a cartridge here. Does anybody still have 8-track? Oh, see? So this brings back old memories. Probably in your car you had an 8-track thing. This is a Westinghouse player. Now I have a thing made in the United States called a transistor radio. You can buy these at the Sunoco station, and I guess it was possible to keep it tuned into KDKA. Now we move into the area that I'll visit after we see some slides. We've gone through the advanced technology of 1965, and our next step is to view what we did in our basement with the rejected boards that nobody else wanted, and how we had fun. Oh, by the way, I'd like to introduce my daughter, Ann, here, and Jay is back with the video camera, so they'll straighten me out if I make any mistakes, I'm sure. I'd like to turn a light out here so that you can actually see that. I've tried to keep this true vintage 1965. None of this PowerPoint computer stuff. Well, the remote's underneath this book over here. Okay, I think we're ready. We've had a chance to see what advanced technology in 1965 was, and a lot of you who have had some experiences with this advanced technology that we're looking at would maybe have some mixed feelings about it. What was Echo 4 a real computer? There are a lot of people who said, well, there were mainframes, you could get time service and put a terminal in your basement, a teletype of some sort, and send off your basic programs and get the results back through a 10-character per second modem. And so you would have access to a computer, but Echo 4, as you'll see, was a real computer. We built the house in Holiday Park in 1961, and I don't want to block anybody here. It was like any other house that Ryan built in those days, except I got in and was allowed to run multi-conductor cable to all the rooms in the house, connect to connectors after the electrician put their wires in and before we put the plaster board up, plaster wall. Down in the basement, I put my hi-fi amplifier down there at the bottom. I don't know if you can pick that out, but it's in there. This was the world's largest hi-fi amplifier. Had 4 tubes, transmitter tubes, and it could put out 50 watts Class A power, flat from 20 to 20,000. And it was a great thing to be able to connect to that to any speaker in any of the rooms. And so that's what the relays up in here did. This was the binary coded decimal clock that we used before we had the computer. These were all done before we had Echo 4. This is the 1300 volt power supply that ran the world's best amplifier there. This is a system diagram, and I doubt that the people on the edges will be able to see it, but it consisted, after we built the Echo 4 system, 4 cabinets down in the basement, down in this level. Programmer's desk is here. Kitchen had a console that Ruth spent time at. We had a terminal for the TV, controlling the TV channels. Had binary coded decimal lights in the ceilings of the bedroom. And this programmer's desk was downstairs, down by the computer. And this was the big termination panel, which I just showed you in the previous slide. All of the connections were made from that corner of the basement. Some people said that we had a computer that the house was built around. Ruth is getting her instructions on how to use the Echo maintenance panel. And this is a diagram that shows some of the connections that were made to these 4 cabinets. These 2 cabinets were the logic and arithmetic units. And these 2 were the memory. Can you imagine? It started out as 4,000 30-bit words, but you could have a half word right or read. So that made it 8K 15 bits, which would be about like 16K bytes. Had 17 power supplies, and you had to start up in sequence. It sounded like a Khyber rifle brigade when that thing started up because of the related skills. Anyway, that shows something about the Echo 4 system. And so if you ever doubted whether or not Echo 4 was a real computer, this would clinch the argument right there. This is the back view of the 2 logic cabinets, and this power supply was from the original Product 4. It was capable, originally it was a 3-phase power supply. When I contacted Duquesne Light, they said you'd have to put the substation on your property. And I said, what? So I changed it into a single-phase power supply, and it had a laundry a dryer plug. Have you seen the plug on your electric dryer? That was the thing that fed 220 into the power supply. Had a half a farad of capacitor. Now, if you were testing over here and the power supply pins got shorted together, with 200 amps and that half a farad there, it was goodbye, whatever it was that shorted together. Pins would disappear. So you had to be very, very careful when you were doing any maintenance back in behind the wiring panels. This is the back of the memory. The core is in this area here, and here are the 17 power supplies. It drew 2 kilowatts when it was running, so our first goal was to not own Duquesne Light. And we decided that the best way to do it was to let the computer remain off until it was needed for a job. So the computer would turn itself on every hour, 59 minutes after the hour, and look around and say, is there something I should be doing? And its only job, most of the time, was to add 1 to the hours on the displays on the binary coded decimals all over the house. If you looked up there and saw that you were off several hours, you knew that the computer was needing some help down in the basement. My father was born in 1903. That's the year before, 1904. That was the year after the Wright brothers flew a Kitty Hawk. He died in 1990, several years after the landing of Armstrong and Aldrin on the moon. So he saw a lot of changes, plus Echo 4. Here was my favorite partner in this whole project. She knew what to do with the boards. I don't know if I ever asked her to do a lobotomy on the top of those North circuits, to clip the top off and get in there with a soldering iron and solder those V notches back together. But I think she could have done it. She built her own Heathkit television, the black and white TV that she built for her sewing room. So I think she could have done it. Wow. And that's just a schematic of what one of the basic elements was and what was inside of it. It was a Westinghouse transistor made out in Youngwood. Now, down in the basement we had a workbench and the programmer's desk and the computer and then an area for kids to play. There's the programmer's desk that shows the tape reader, tape punch, a keyboard for entering data, and there's a printer, the Kleinschmidt printer, which I converted into a parallel printer from the serial printer that it had. And this is my crowd that liked to see what was going on. The system was designed so that you could turn it on at any time that you needed it to be on by just pressing a key on the keyboard, and then the computer would come roaring up to life. In theory, that's what it's supposed to do. This is Sally, our daughter, who lives in Indiana and couldn't be here tonight. But that expression I've seen on a lot of people using computers. Yes, you're surprised.
I guess it's Sally Clear.
And, but she was our good helper. Here are some of the cartoons that were coming out in the newspapers and magazines. If you think this machine is complex, you should have seen the woman it replaced. John, I think our home computer should know I'm leaving you. Can yours grind corn, crack nuts, and sharpen spears? If it couldn't, then it's obviously no improvement. And finally, but if you can't use it to kill dinosaurs, what use could it possibly have? There's always critics that any project you've ever worked on, I'm sure you see that today, they'll take the negative approach to whatever you're doing. And you have to forget about that and press on. Okay, we're entering now the area of tasks that the Echo 4 performed. It wasn't just an expensive boat anchor, it was actually doing some work. It could execute these machine language commands, which were pretty good. Reset, as long as it could subtract when we thought it would be doing our accounting, she'd be happy. But the halt instruction was pretty important. It was done with all zeros. So if you ever brought a word out of memory that was all zeros, the machine would just suddenly stop. And that's much better than allowing it to go roaming out through the woods and doing all sorts of neat tricks. Some of the applications I've mentioned, the binary coded decimal clock driver, it would do hour field every hour, and if necessary, it would document the day field in the table. The alarm clock was a series of switches in binary coded switches that you could set up for a time that you wanted some event to happen. And I think there were 10 different events you could program. This was in our bedroom on the desk. The stereo system power was also controlled by the computer. It could turn the power on and select which speakers would send a signal into your room. TV controller had a little console that you could type in or press in the channel number, and the TV had a motor on the front, and it would move the tuner to that particular channel. But then also, it would turn the antenna on the roof to point to the proper station to match. On school nights, we never implemented this, but the plan was to have it fixed to ask a question of the kids, and if they could come up with the right answer, they could watch TV. Otherwise, it was a blackout night for the kids. One program instruction that I have always loved, and it's clear a room of programmers, called jump, because you lose control pretty quick if you execute that jump and you can go anywhere in court. Well, every time I could write a loop of various length, counting the number of commands in that loop, and as the execution of that loop was taking place, it would hit the jump, spit out a little pulse to a speaker on the maintenance panel, and then continue to do that and produce a tone. Well, it didn't take long to figure out how to code Silent Night and O Come O Ye Faithful. So at Christmas time, we had it playing on the hour. Even hours it was Silent Night, and odd hours it was O Come O Ye Faithful, all night long. And it was sort of tough to know that the computer had come on and it was not out in the weeds simply. We solved some problems that were impossible for us to solve ourselves. Anne was, I guess, 7. No, how old were you, Anne? When you came home with the problem that the teacher asked you to... 6th grade. Teacher asked Anne to, along with the other kids in the class, to calculate what 2 raised to the 120th power. Because if they considered, fruit flies that can multiply every 30 seconds or 30 minutes, they were wanting to know how many fruit flies would they have after so many days. And so Ruth, Anne told me about this, and I went down and programmed in machine language this very problem. And it was very successful. But she took the result in and showed it to her teacher. He had worked it out by hand.
Oh my heavens.
He didn't think they should use any other machines, calculators, or anything to do that. And of course, when you get above 40 or 50 decimal places, calculators don't do you a whole lot of good. Well, anyway, he found an error or difference in Anne's printout, and he concluded that his was got to be right, because he had done it himself, and that Anne must have had a bad computer program. Later, Jay, who's back running the video camera, came at age 6, was wondering where would be the upper limit on how many decimal places you could make that. Well, I figured it was the width of the typewriter plate, because with this machine language program we wrote, there was really no limit to how many decimal places. And so I have the printout here on the table, which you can look at, that shows 2 raised to the power of up to 204. And it's when it was hanging on the wall in my office, we called it half a Christmas tree. Okay, there's just one more here. Ruth was invited to come to Dallas in 1967 to speak to the National Convention of the American Home Economics Association. So we had a handout that showed a flow chart, and that flow chart converted into the mnemonic code, and then the octal code to do that job, and here was your favorite cartoon. Then we asked a question: what would you do if you had a computer in your home? And I had the results of that over here in another paper, which I can pass out to you later. Here's Anne teaching us about binary coded decimal. The red circle represents a light that's lighted, and so this is the 1, 2, 4, 8 section for the minutes, and so the 4 light is on. There's the 4. Over here you have 1 and 10 and 20 on, so they add together and make 30, so we're up to 34. Over on this side there's a 1 and an 8. So by adding 1 and 8 together, you get 9, and so it's 9:34. Fortunately, our kids could look at that clock and immediately spot 7 because that was 1 plus 2 plus 4. And without even thinking about it, they knew what time it was by glancing at the binary coded decimal clock. They were somewhat of an disadvantage when they went to school and had to learn about the big hand and the little hand. This was the clock that we had down in the living room. It had seconds in addition to the minutes and hours, so it was really good. I have this one in our family room here in Monroeville now. This is the controller for the TV set, and Ruth is showing how easy it was to just press in 11 if you wanted to watch channel 11, and there you go. In the kitchen console, Sally was showing Ruth what she had typed on this typewriter. We used this typewriter then to type Christmas newsletters. It had a red and black ribbon, so it was possible to personalize a Christmas newsletter with red. Some of the letters were red and others were black or green, whatever it was. Jay preferred to use it to keep his cat warm. The cat liked to sleep up on top of it, so like the typewriter. I guess it didn't really like it a whole lot when the typewriter was typing out, but that wasn't a big problem for it. Okay, now let's get some lights on, and I'll see what we can do here. One of the things that the Echo 4 did for us, it typed out the text for this 535-page book that I wrote called Original Land Grant Surveys Along Green River in Kentucky, 1781 to 1836. It took a long time to plot these early surveys, but I found that my great-great-great-grandfather had come in there in 1798, had a square 200-acre parcel along a river, and it was impossible from the description to figure out where it was. But by taking all of the other neighbors that had their plots, it was like a jigsaw puzzle. When you put it all together, you could move it with the landmarks over here and landmarks over here, and these, my great-great-great-grandfather's farm just went along for the ride as this was moving across the geodetic map. It was a wonderful project. And so I had all these surveys and decided that the Bicentennial Committee in Casey County, Kentucky needed a project. And so they decided to print the book if I would print out the text. We had fun. This is a picture of us in one of our happier times. This was taken by the Post-Gazette. They were trying to show that weather forecasting would be something that we could do with Echo 4, and that grocery lists would be something that it would do. And I don't know what they thought that I would be doing over at that keyboard, but at least that was the problem. This was an interesting puzzle that the Echo 4 worked out. I don't know, has anybody ever heard of instant insanity? I'm glad you came. I'm glad you're here. This was a puzzle that Parker Brothers put together and sold thousands of these. I'm surprised that you've not seen it. But these little blocks are all independent, and they can be turned any of 6 different ways. Had 331,000 possible combinations. But the goal was to line it up so that there were 4 different colors on each of the 4 sides. So you see what the problem was. You're trying to do this. Well, I figured there's probably one solution, but maybe there might be more than one. So I programmed Echo 4 by assigning numbers to each of the colors and adding them up, and by using 1, 2, 4, and 8, the only side that had all 4 numbers would equal 15. So by adding those up, if it wasn't 15, that was not a solution. But then you had to go and look at the other side to see, was that a 15, or was this side a 15, or was that side a 15? Then it rotated the sequence of numbers and did it all over again, exhaustively. It took about 20 minutes for Echo 4. Some of my friends said they did it at the computer center in about 15 seconds. thought another algorithm of some sort. But anyway, this was the... Okay, I have handouts which I'm going to give you after you hear Ruth read a paper that she presented at the National Home Economics Convention in Dallas, Texas. 2,000 people in the main auditorium. They all were just enthralled with Ruth. So, Ruth, you want to come over here? Or... I think this is working, right? Stand over here and talk to the art and flip this on. Yeah, this will work. Up close here, you say. Okay.
Okay.
You can put that. You can put it.
Okay. Can you hear me?
Yes.
Okay. Well, I don't know how we got in contact with the people that were wanting to find something to make homemaking easier for us. And I think all of us will raise our hand and say, please, please, bring it on. But so far, we haven't really been able to bring the scope of the home computer completely to take care of all of our work. I thought, how in the world am I going to go to Texas and give a paper on something that I barely know anything about? You have to even learn the jargon that goes to the computer world. And when you have a child that doesn't really like to stay in one place, it's a little hard to get to things that you don't do when you have a baby around. And okay, it's been a long time since I looked at this. So, but at first, when he started talking about bringing these pieces home that he could make something out of, this wasn't unusual because he was always making something out of pieces he brought home. Sounds like a few of you may be of the same type too. But anyway, we got through, and I was able to do this little paper and get it sent to Dallas and get it arranged for the family to go. Not the whole family. But then there were reporters that came and wanted to see what this computer was doing. Then there were reporters that came and wanted to write what they wanted the computer to do because it made a little more interesting article. So this was an element of this whole computer bit that none of us really expected people to be interested. Okay, he's trying to hurt me. Okay. Well, anyway, I'll start reading. At first, I really did think it might replace me because he spent so much time on the project. But that was his nature, so I can bear that. So Jim started talking about the availability of parts of an obsolete Westinghouse computer that could be made into a computer for home use. It wasn't long until one wall of the dining room began to fill up stack after stack of these computer cards in their containers. And anyway, the dining room kept filling up until he got the circuit designs made where he could even sort out what he had, what he could use. Okay, and I call this stuff junk because for anybody looking at it, it would be junk, but it was pretty important in running a power plant and doing other commercial things. So, as each portion of the computer was finished, family, which included Anne, now 11, and she's 50 now. Okay. As each portion was finished, the family, which included, this is a repeat, and 11, Sally, 7, and Jay, 2. They all used to run to the basement to view the latest accomplishments. The biggest day was when power was turned on and nothing blew up. One day, during the early testing stages, a neighbor child pressed the keyboard switch and turned the computer on. It was then that I realized I didn't know how to turn the thing off. And short of turning the power off the main circuit breaker of the house, I could do that. I'm sure the fellows at Jim's office thought I had gone kooky when I asked him to leave this message for him. Please call home. The computer is running. How do I turn it off? And incidentally, kids, in those days, we did not call our husbands or friends at work. You just didn't have access most of the time to a phone. And you never knew when the men were coming home. If they got involved in a good project, they could just work past time levels. And you'd have to somehow, but we did not converse through the workday with husbands or with boyfriends or anything like that. Let's see. Last week, well, this is written in '67. This is one thing we were doing. Last week we needed some address labels for the tape recorder cartridges that we mail as letters back and forth to our parents. It wasn't long until Jim gave us a call to come see what the printer was doing. There it was, typing out the address and return labels on sheets of gummed labels. The program is now stored in the memory and unit, so at any time these labels are needed, a certain code typed into the keyboard will cause the printer to type it again. Our kids had no problem looking for gummed labels. We didn't have those 50 years ago as regularly as we had them here. Okay. I think I should just let them have
it. His computer turned the page.
Okay, I'm going to let you do it. All your messes tonight.
Good job, Ruth.
She said she was second. The first thing was that she was hoping that the computer would do things that took a lot of her time, like raising kids. Secondly, she said, I'm excited about a computer in my home to relieve me of some of the more menial tasks that I have time to do those things that I really enjoy, like carrying out ideas for home decorating and working outside the home with flowers and gardens. And I find a need to have time to work with the young groups. And thirdly, I'm excited about a computer in my home because it is something that our whole family can use and has already enjoyed. With proper instructions, any school-age child will be able to use it as a tool for classes, or games, or actual mental exercise. Even if they were available for home use at a reasonable price today, the word computer is a little frightening to the average homemaker because she has had no experience or personal contact with one. Homemakers must know that a computer only does what it has been told to do through a program that has been written by someone who knew how to do the job. It's like a child, except it's better. The child knows how to do it after it's been instructed, but sometimes he doesn't always carry through with that. One important difference is that the computer always does it exactly as you program it. Therefore, one source of frustration to the homemaker is relieved because she is working with a device that always precisely is predictable. At this point, I cannot say or even comprehend all of the things that a computer someday will be doing at our home. But wouldn't it be wonderful if they could provide more time for parents to spend with their children, therefore making every home a happier home? And finally, I'll talk just a bit about the publicity that Westinghouse wanted to get out of this project. And so we have the articles that were in Popular Mechanics in 1968, and also we have 30 years later when Popular Mechanics came out and mentioned that same article 30 years later as they were talking about. The other issues of Byte and Science and Mechanics, there's a picture of Sally and Anne, which are sort of interesting because they showed what the writers thought that a computer could do at a home, and they used their imagination. I figured at one time, our son Jay, who was only about 8 or 9 at the time, knew more about what the computer was capable of doing than the writers of these articles. But anyway, it was fun. We had, if I can go to the very last part of this thing here, we'll let you get out of here before midnight. The Associated Press wire that got out of Allegheny County in 1970, down here at the bottom, is the big one. That's the one that went to 77 million readers. Westinghouse paid for a company to have clipping service to clip out articles that mentioned Westinghouse, and so they were quite happy that the other one was 50 million that went in in June of 1970. So these two were really very well received downtown Pittsburgh. The others were starting in '66 and generally local. Here's that Popular Mechanics, Computer World, Datamation, Science and Mechanics, Computers and Automation by Creative Computing, and the Computer Museum Report. This came out in '85 after we donated it to the Computer Museum in Boston. The answer to this question, of course, is last time we saw it in Pittsburgh was on the back of a truck. This was the memory unit, and it was going on to Boston. And later that year, we were in Boston, and we stopped. And I had this picture taken of the logic and arithmetic unit, and the core memory, and the printer, the TV controller, the book of all the programs that we wrote, and the keyboard. Now, in 1998, all of the exhibits there in Boston were shipped out to Mountain View, California, near San Francisco. And there they have a new museum now called the Computer History Museum. Way off in the attic someplace in the storage area, Echo 4.